Good morning everyone. I am VM Nandini. Today I am here to explain physics behind beverages. Let's start. First, let me say the overview of my topic. Besides being the favorite beverage of a large percentage of population, a glass or a bottle of beer is a test bench for myriad of phenomena involving mass transfer, bubble laden flows, natural convection, and many more topics of interest in physical chemistry. This paper summarizes some representative physical problems related to bubbles that occur in beer containers, pointing out their practical importance for the industry of beverages processing, as well as their potential connection to other processes occurring in natural sciences. Now let's see about carbonated beverage. The two essential ingredients of buddy drinks are water and carbon dioxide. Of course, their flavor and texture become more sophisticated when incorporating other ingredients which usually come from plants, but sometimes from chemistry labs as well. The carbon dioxide they contain might be generated within through the fermentation or may be injected and dissolved through mechanical means. We now explain some physical principles that are at the heart of bubble growth and motion in drinks, and that are necessary to discuss the rest of the topics in this place. Now let us see about bubble nucleation and growth. Once a drink is oversaturated, a crucial question is how bubbles come to form. This implies creating a gas liquid interface within the liquid matrix, which has an energetic cost. At the oversaturation condition of beverages, bubble formation requires the presence of nucleation sites, which might be provided by contaminating particles or surfaces in the container. The energy implied in the existence of an interface gives rise to an overpressure delta PL known as Laplace pressure, and it is given by delta PL is equal to 2 sigma MA by R. Now let's see about Henry's law and oversaturation in beverages. The first principle, Henry's law, states that the amount of gas that can be dissolved in a liquid is proportional to the partial pressure of gas above the liquid. This is given by C is equal to KHP. One may observe that the effect of Henry's law when opening a bottle of beer or other carbonated beverage, carbonation level in typical beers are around 4 to 5 gram per liter. Whereas the equilibrium concentration of CO2 at serving temperature is around 2.5 per liter. Upon opening a bottle, therefore, the system will strive for an equilibrium and bubbles are formed as CO2 is released into gaseous phase. Now let's see about buoyancy and circulating flows in beverages. Finally, the fact that bubbles rise will be a paramount importance in the following discussions. Their ascent is due to buoyancy Fb, described by Archimedes as the upward force experienced by any body submerged in a liquid. This force is equal to the weight of the displaced liquid volume. For the case of sphere, Fb buoyancy force is equal to 4 by 3 pi r cube 3g rho liquid. With being g is a gravitational acceleration. Whether an object rises, sinks or floats neutrally depends on the balance between the weight and buoyancy force. In the case of bubble, since it is a density, rho gas is much smaller than the liquid, upwards buoyant force will always be larger than its weight. Weight is equal to 4 by 3 pi r cube 3 rho gas. Now let me conclude about this topic. In the previous sections we have described a selection of physical phenomena involving bubbles that can be commonly observed in beer. For instance, we have described bubbly waves that sink instead of rising, how an apparently mild impact on beer bottle is able to trigger a beer volcano, or how shaking reduces the pressure inside a container instead of increasing it. Most, if not all, of these phenomena have important implications for the beer industry as they affect the way of beverage is brewed or transported. A remarkable feature is that once the physics behind the phenomena is understood, very similar processes are observed to occur in nature in applications apparently unconnected to a beer glass. Thus, our beer glass, besides being physically pleasant, can be seen a small scale laboratory of a very rich variety of physical phenomena that range from geological flows of water waves rolling downhill on a rainy day. Thank you.